This is the first, I handed out 2 sets of papers. We won't get to one for a couple, I don't think, certainly won't do it today. The first one is just Alfred Wegener and plate tectonics. Now, we talked about J. Harlan Brett's back in a couple classes ago, and he said, I repeat, ideas without precedent are generally looked upon with disfavor, and men, the scientific community in particular, are shocked if their conceptions of an orderly world are changed. Okay? That's Alfred Wegener. So now I've tried to put most of the words that you're going to have to fill in blue. In fact, it's been hours doing that because I adjusted this from previous times. Brett's argued that deep canyons and Potbar buttes and scablands had been created by sudden catastrophic flood, not, as by most of his peers believe, by eons of gradual erosion. Now this is quoted. What I'm quoting here, the quotation marks there, all the way down to the end, that's from the Smithsonian, a magazine that was started by a Christian, but has evolved into something considerably different now. It's not pro-Christ, it would be anti, I think pretty much of what they have now, but in the very beginning, it wasn't. But when so this is written by them, and so he's saying, not as most of his peers believe, it was a bold challenge to the prevailing principle of uniformitarianism, which means, as you may remember, the present is the key to the past, which held that the earth was shaped by processes that can be observed in the present. Since a cataclysmic flood of almost biblical proportions envisioned by Brett had never been seen, it was dismissed as a throwback to the pre-scientific doctrine of catastrophism. So you throw out the word catastrophism, and all of a sudden, scientists out there raise a red flag, raise one with both hands. There's something, oh, watch this person, guy or girl, watch them because they're in deep cotton as a red, can't remember his last name. He was an announcer for the Yankees back in the day, way back in the day. And that's what he said, out in deep cotton. They were way out. Well, okay, so that wasn't helpful. If I was Mike Adams, I'd cross that one out. But I'm not, and I won't remember it anyway. So his theory was eventually seen to be accurate and an accurate assessment of observable data. So what he said was right. But so after 50 years, almost, of rejection and ridicule, he was exonerated. At 96, he lived a long time, he was awarded a nice medal by his scientific peers. So hooray for the scientific peers. What's the point? Observational science is often initially dismissed by those holding to ideas or theories held by consensus, like the group gathers together, like the Big Bang theory. Many people in the field the sciences, not just the field of biology, biological sciences, or geological sciences, or chemical science, or mechanical science, or they all could wear a white coat, but whether it's like looking to Hollywood, people to be interviewed from Hollywood to give you answers for today, for yourself. I mean, where do they get their expertise? They don't. They just got money in the pocket. Well, that's not a good enough reason to give advice or counsel. But anyway, consensus scientific peer pressure. And number 2, observational science generally presents the strongest case for supporting scientific hypotheses. Observational science. Again and again, you're going to get that. You're going to see that in blue several times. The science of Alfred Wegener is another case of the established scientific community rejecting hypotheses based on its prevailing but erroneous ideas. Close examination of a globe often results in the observation that most of the continents seem to fit together like a puzzle. The West African coastline seems to snuggle nicely to the east coast of South America and Caribbean Sea, and a similar fit appears across the Pacific. So that's, most of the maps you see, they're looking at the edge of the continents. But if you take the continent ledge out, the continental shelves, which are a continuance of the continents, like we're going to talk about subduction, the oceanic crust subducting under the continental crust. Well, the continents don't just stop when the water is there. If you've ever been in the ocean and you walk out, you can walk out a long ways, and that's the shelf. So it goes a long way. When the shelves of the continents are compared, not just the edge of the continent down to the water, it's more striking. It's really very clear. So, in 1912, Alfred Wegener noticed the same thing and proposed that the continents were compressed into a single proto-continent, which he called Pangaea. And over time, they have drifted apart into their current distribution. He believed that Pangaea was intact until about 300 million years ago, when it began to break up and drift apart. However, his hypothesis, Wegener's hypothesis, lacked the geological mechanism to explain how the continents could drift across the Earth's surface as he proposed, which is reasonable. If you were a scientist and you heard him present his information in 1912, and you would say, well, how would that happen? And scientists of his day didn't believe that this crust moved at all. And he didn't offer, initially, some explanation for it. And he should have. Now, then,
in the year of 1910, there was a scientist whose name was Alfred Wegener. He noticed that the continents looked just like pieces of a broken puzzle. By 1915, he called it continental drift. It caused a rift with his fellow scientists who sang, ha ha, Alfred Wegener, you are a crazy man. Ha ha, Alfred Wegener, you are a crazy little man. They reminded him he had no proof for how or why the continents could do this. And until you show just how or why, you merely have one interesting hypothesis. Until this evidence we see, you don't have a theory. Ha ha, Alfred Wegener, you are a crazy man. Ha ha, Alfred Wegener, you are a crazy little man. In the year of 1930, on an expedition to Greenland, Wegener got caught in a blizzard. When they finally found him, it was much too late, and they buried him in an icy mausoleum. 30 years after he died, a new idea came to light. It changed the way geologists saw the world and brought continental drift back to life. Now everybody sings, yeah, Alfred Wegener, you are a brilliant man. Yeah, Alfred Wegener, you are a brilliant, brilliant man. Continental drift, Alfred Wegener's theory, continental drift. Alfred Wegener's theory, continental drift. Alfred
We need more of this.
I feel like I can grasp continental drift.
So, we'll see more of this, they're funny, these guys. So, searching for evidence to further develop his theory of continental drift, because, as you see, he was talking about something that was pretty incredible. I mean, the movement of plates, and people at that time didn't believe plates were moving. In fact, up into the 50s, there were still people that believed in different ideas of how things were happening, and they didn't buy into this necessarily. So what he was proposing required more. Okay, so I believe that the crust moved apart. Well, then how did they do that? What mechanism would produce that movement of crustal plates? And mountain building and other things. A lot of things had to be considered. Well, he came across a paleontological paper suggesting the land bridge had once connected Africa to Brazil. This proposed land bridge was an attempt to explain the well-known paleontological observation that the same fossilized